So now let's start on our next topic, SQS. So SQS is simple queuing service. So in this, this is used for decoupling the application. It's like when like hundreds of files are dropped into S3 bucket, then you need to trigger Lambda, right? So in that case, hundred of files cannot be directly sent into Lambda, in which it's like it might be like 50 of the files has been processed properly and 50 of them hasn't been processed properly. So in that case, you won't be able to know which files has been processed and which hasn't been. So in this case, SQS will come into action. So for this, how SQS works is like after getting the 100 files into the S3, there are two ways SQS will work. The configurations are first in, first out, and the number of batches of data you are going to send. So in first in, first out is like the number of data that came that will be like processed in the FIFO queue. So the first data, the event for the first data will be sent to the Lambda. It will be triggered. After that, the next data will be going on to the 100th one. And the next one is like a batch one. So in that case, it will send the batch of 10 data to the Lambda. So like in case of 100 data, 10 of the Lambdas will be triggered, in which each of the Lambda will be getting the message of 10 data. So like this 10 data has been dropped in S3. So this 10 data should be processed by the Lambda. So in that case, it will work. So now, how will it help in the case of failure? So SQS has built-in retries by itself. So might be a file name 123.txt has failed in the processing. Then SQS will retrigger the Lambda by itself. So in the first case, it's like it failed. The Lambda failed. It will retry. The Lambda will retry by itself for the 3 times. After the failure of the 3 times also, then SQS will be coming into action and it will retrigger with the same data for the second time. So after the 3 times, the data hasn't been processed properly, then it will skip the data into the date later queue. So it's just like SQS, but the data which hasn't processed properly will go into date later queue, and it will stay over there. So this is after that, if you want to run for the same data again, then you need to configure the date later queue to trigger the Lambda again. So that's how the SQS works. So it's simply like processing the data in the queue for the Lambdas. So that's what SQS does. Did you guys get it, what SQS does and why it is used? So it's just like a queuing service. You get the data into S3. It will the SQS will be triggered after the data is in the S3. The SQS will be triggered. The path of the data, name of the file, everything will be taken by the SQS, right? And the SQS will trigger the integrated Lambda with the sending the path of the data that the data has been where the data has been dropped, and the Lambda will process the data. In case of failure, the Lambda will try 3 times by itself, right? So in that case, if the Lambda failed for the 3 times, the SQS has the retries of 3 times input. Then SQS will be triggered by itself and send the data to the Lambda again. It will run again 3 times. It's a second failure. Then it will again go to SQS and it will say like this time also it has been failed, so you need to trigger it to your passive. So SQS will trigger it again, and the Lambda will run. So after the failing of 3 times, so like it's like the Lambda has been filled for 9 times, and the SQS trigger has been filled for 3 times, right? After the third time, the path of the data and the name of the data, the file, will be in the date later queue. That means like all of this has been filled. Now it will go in the date later queue, right? And it will stay over there. Date later queue is also a space. It is just given a name because like when the file is filled, then it will be easier for us to recognize that it's on the DI. So that's the only thing. And again, for the next time when the SPS runs, then the filled file will be triggered again by the SPS. If the same SPS runs, then. So that's how the process continues. So if you don't want that specific file to be run again, then after the completion of the process, you need to go into the SPS console and purge the SPS so that there will be no any message in the SPS for the next trigger. So that's how SPS is going to run. So SPS is used to trigger the S3, like SQS is triggered by the S3, and SQS triggers the lambda for the execution. So this is the overview of the SPS. And so after the completion, like we talked about failure, right? But what in case of success? So if the data has been processed successfully, then the SQS deletes the message by itself. And the other thing is like you can keep the timeout visibility for the message in SQS as well. So the messages are processed. The in case of failure, the message itself remains in SPS, right? So in the timeout visibility, if you keep the 1 hour timeout visibility, then after the 1 hour, the message will be paused from SPS itself. So you don't need to go and like post the message from the SPS. So this is how SPS is working in case of serverless architecture. So it's like decoupling microservices, order processing service, inventory management service. Like it's gonna send the data in queue for the different lambda to trigger it by itself. And load balancing between tasks. So it's like I said, like you're gonna get 100 of data in bunch of 10 data are sent in a SPS message to a single lambda. Then 10 10 lambdas are triggered, right? So in that case, for 100 of data, there is being a load balance, right? So a 10 data is in 10 data messages are going into a single lambda, then into another 10 into another lambda. Like it's gonna be like 10 data in single lambda, right? So there are 10 lambdas triggered. So it's going to be load balance and the processing is going to be faster rather than 100 data in the same lambda. And asynchronous processing, like I said, like if it's failure, then it will say like trigger again. So in that case, it's going to be asynchronous processing. Like it will be continuing working on it. So these are some of the SQL commands. Do you guys have any problem in SPS? Understanding it? It's just like a single queue, nothing else. Like when you go into canteen and you stand over there for taking the lunch, right? In the queue. But if we had over there different 3 or 4 tables and utensils where the lunch are kept, and if you could take it from 3 or 4 tables, then it would be the balance of the load will equally fall on the table, right? So, but now there is only a single place from where we can take the lunch, and yeah, it's going to be pressure is on that table only. So everyone has to be over there on the long queue to take the lunch. So the same concept is for the SPS, nothing else. What do you guys? Any questions for this one? So here comes the next SNS, simple notification service. So what will be SNS? Can anyone of you try? The slide is in front of you. You can study there and try once.
Sorry, so send notification. Notification service.
It's on the topic, it's it. After reading this, can any of you read one of the examples where SNS can be used? Once let's try that. That would be one.
Log system that something files created and saved to the next team or something like
That can be also be done. That won't be integrated in SNS. That can be used like that can be done. So SNS is nothing but it's just a notification service. It's a cloud service for sending messages and notifications. So one of the example could be like uh, might be you are the manager of a team and you guys are working on her. And in that case, she is looking over all of the cloud services. She has the full access to S3 and like you have the get access, you have the put access, and you have the like delete access, right? So in that case, she needs to monitor like who kept the data in the S3, right? So if you keep the data in the S3, then after the data is in the S3, like uploaded in the S3, we can configure in a such a way that SNS notification will be triggered, and the SNS will send the email to the manager regarding that this file has been uploaded in the S3 in this path by this person. That can be done. So this can be a simple use case of SNS, but others might be like I am running. I have a big architecture. I'll talk about the architecture after this, but it's like I have a Lambda running, so the Lambda fails. And after the failing of Lambda, we can write a code that if the Lambda fails, then figure the SNS and send me the logs like why the Lambda failed. And the logs will be sent me to in the email. Not only that, SNS can be used for messaging in the phone, emails, or messaging inside the AWS services also. The S3 SNS can message to the AWS Lambda. So the interconnection of the messaging system can be done by SNS. So it's like an anchor which delivers message to the whole audience. Amazon SNS can send message to many recipients at once. You guys are sitting in front of TV, right? You all of you guys are sitting in front of TV, right? And like 10 of them are watching the TV, and news anchor is saying like the weather report is like this and this for the today. And from the single place, you 10 of them are getting the message like about the weather, right? So this is the same process how SMS works. And the next thing is like you can send message to phone, emails, and other applications and reliable. It ensures that message then don't get lost. So like the message sent by SNS doesn't get break or lost in the between. It reaches to the end users anyhow. And the next thing is when to use Amazon SNS. Notify when something important happens, sending message automatically from apps or systems. You can automate the message from a Lambda function when something happens and like send it on like regular basis with the event which triggering the Lambda function. So in that case, it's like you want to send the message to all of the group each week at the end of the week, but you want to make it automated. You are going to create a SNS. In that SNS, you are going to upload the email of all of the users sitting over here, right? And you have to send the email saying that it's you got to do these things on Saturday and Sunday because you have holidays. So in that case, Friday on the Friday 10 p.m., I'll create an event page which will trigger the Lambda function on the Friday night 10 p.m. until the bootcamp ends. Right. So in that case, the event page will be triggered at the 10 p.m. itself, Friday night, and the event page will trigger the Lambda. Lambda, there will be a script integration with the SNS, which says like do this on Saturdays and Sundays. So it will be automated for the every Friday until the bootcamp ends. So this can be one of the use case of the SNS as well. So you guys have any of the questions regarding SNS? No questions? Then I'll ask questions afterwards. So these are the SNS commands. You guys have to look on yourself these commands because you guys have to use the AWS CLI by yourself, looking on YouTube or documentation or anything because AWS has a huge level of documentation by themselves. So this is one of the serverless architecture that we are going to discuss right now. So can anyone, as you mentioned, what's going on over here? Seeing the architecture once? Let's try it from your sides. Kuni guys, could you try once?
So you want to first to explain this.
Yeah, anyone can.
So
Like, it's a data architecture. What's going on inside that?
it is a simple architecture. The user drops the image in a bucket, which is forwarded to simple querying service, and then which triggers the lambda function, and the lambda uh, sends the image information to the database, dynamic database, and then it's resized and sent to the S3 pocket at the same time, which triggers the simple notification service, and the notification is forwarded to the end user.
That's right. Now I'm going to add something in this. So there is if you do like user drops image in S3 pocket, right? So in that case, what we can do is like we can create an API gateway due to which a lambda is triggered and a data image is dropped into S3 pocket. That's going to be like front end of the website. We can add a front end, and when uploading, like it's like we are going to add a front end over here. And when you are going to upload the data, and after the upload is completed, it will directly go and store in the S3 pocket, right? So after that, the S3 pocket triggers SQS and send message like this file has come into this folder of this pocket, and that specific file, the message of that event, total event, will be sent to Lambda. Lambda recognizes the file, like which file has been sent, because everything has been sent in the message itself. So after that, the Lambda lists all of the things, all the events, and says, look, now I'm ready to with the files, and I have read the file and recite the image. Now, what to do after that? So then Lambda will save the image information, like this image has been resized from this size to this size in DynamicDB. And the same image will be given in the S3 pocket, the resized image. So why did DynamicDB is used here is like we want to ensure that we want to like audit, like if it has been resized or not. So if the data is in DynamoDB, it has been resized for the specific file, but if it isn't there, then the lambda has been failed. So in that case, we can use the DynamoDB to check the failure and audit the data as well. So that can be next thing use case of DynamoDB. And in case of that failure of lambda, we can integrate SNS notification as well. So the lambda has been failed in this step with the log this, and we can send the email to the end, the users, like the backend users, or might be the developer of the architecture, right? And then the data has been saved in the S3 pocket. And after the data being saved in the S3 pocket, the SNS is triggered, sending email to the end users. So now, like rather than sending email, we can send a notification in the front end saying that the image has been resized. Now you can go in this pocket, this folder, this file name, and check the image like it's proper now. This is the whole architecture. This is how the small storage architecture works. And we have a next one as well. So this is a complicated one. So it's like we have a platform in which like we have a platform which has been integrated with Snowflake's or database, right? So it's all integrated platform. And in the Microsoft Outlook, we have single sign, SAML. So in that case, like if you sign in a specific account, you're gonna get access to each of the account. So for that case, you need to have the password same. Everything should be integrated in one, right? So in this case, like it's like a web application being associated with Snowflake. The same username and password for accessing the web application will be used for accessing the Snowflake in this case, right? So it's like when you change the when you have the password for web application, then how you can determine the password change in the Snowflake? This is what the architecture is talking about. So in this case, it's like the web application is deployed in AKS, right? So when the password is changed in for the web application, when I change the password, then it will be redirected to Aurora database, saying that this user has changed the password from this one to this one. So and it's encrypted in the Aurora database. So after that happening, Aurora database has kept the update trigger for the lambda function. When the data has been updated in the database table, the lambda is being triggered, saying that now use the API of the Snowflake data and update the password for this user from this one to this one. So the Snowflake, the Lambda will use the API of Snowflake and update the password for the specific user of the Snowflake. This is how the serverless backend is working in this case. So this can be the another use case of serverless backend. So there are lots of use cases for serverless backend. From data processing, image processing, to the changing of passwords, for the notification things, like tons of applications are there. So talking about because we are mainly focused on the serverless backends only right now. So we use EKS very like really. We highly use Lambda functions, SNS, SQS, DynamoDB, all of these things because like that's cost effective. And if we have some of the code that takes an hour or 2 hours to run, then in that case, we try to decouple the code and application and try to implement in the different Lambda function. But if that is not possible, then only we go into the server platform. Otherwise, it's best for us to use the serverless platform over here. So this is the another example of serverless backend. So do you have any questions till now? Sure. So it's like operating in database is for your own web application, for the company's application, right? And operating in the Snowflake is for the accessing the platform of the Snowflake with the same password and email ID. So that it won't be hassle for you to remembering hundred of passwords. So you are only going to use in companies you use tons of accounts, right? Like you're going to use database, Snowflakes, AWS, and then Outlook, Power Automate, everything. But how could you remember the password? So like when an application is integrated with our own application, then we try to do what we try to do is like if one of the passwords is changed in our application, in our platform, then it should be redirected to other platforms as well. So in the Snowflake, it's the same case. The thing for Snowflake. So I think the serverless ends here for now. This is all about the serverless. We are going on and it's completed. So do you guys have any questions? The part of serverless? Guys, do you have any questions? Did you guys understood all of the things? Really? Because it took me around 1.5 months to understand all of these things.
Hello.
Hello.
Sir, in the serverless backend example, sir, what is EKS?
So that elastic Kubernetes service. So that's not a part of serverless, but that's the part of server itself. So I didn't talk about this in depth.
Sir, why is it used in the architecture, sir? What's the utility of that?
So it's for deploying the web application. So web application should be deployed somewhere. The web application is accessed time to time by every of the people in the company, right? So in that case, you can't use the highly accessible thing in a serverless thing. You need to have a server in it for being hosted for all of the times. So EKS is being used over here in that case. So the main thing for
Okay.
us is to look on the how the password changes using the serverless architecture rather than EKS for now.
Okay, sir.
So EKS is just a Kubernetes only, nothing more than that. Do you guys have any questions? I'm amazing, no questions at all. Should I assume that you guys understood everything, or should I assume that you guys didn't understood anything, so that you don't have any questions?
What is decoupling of microservices and that was associated with SQL?
So it's like when it's like decoupling of microservices, it's like you're gonna decouple the application. It's like you're gonna give a single task to a single thing, right? Decoupling means like not keeping the pressure on the single thing only, but distributing the tasks on different things, right? So in this thing like decoupling of microservices, like when you are using the SQS, it's gonna have a FIFO service, one's like a FIFO queue, and another is the standard queue. In the standard queue, it's like you're gonna assign the number of batches of data to the of messages to send in the further for the application to be triggered, right? In FIFO, it's gonna be like first come, first out. Right. So let's talk about the batch. So in this case, when you send, like when you got thousands of data in S3 bucket, and you have assigned 10 of them for each lambda, for each queue. That means like 10 of the batch on for the single lambda, then another lambda, and another lambda. It's gonna create for 1,000 data. It's gonna create hundreds lambda, right? So in that case, the application is being decoupled, and the message that's being sent into different lambda, right? So this is how the decoupling makes sense in this thing. So I think I should ask questions now. Some of the questions. Let me see. So I talked about API gateway, right? So I just gave an example about the API gateway as well. So I haven't gone deep into API gateway, but within your understanding, what API gateway is? Will anyone say? Sorry. Yeah, that's the thing. But how does it connect? Because I have given two examples of the connections as well. Yeah, that's the thing. Like it's like when you have a post API, get API, or like any of the API methods, then you're gonna create different APIs for the single one, right? So in that case, like what API gateway can do is like when the API is triggered, the API gateway is directly redirected to the Lambda for checking if it's post, get, or anything. You have to keep you have to specify in the body like it's post or get while triggering the API, right? So after the Lambda is being has been triggered, then in the get API, you might need to get some data from S3, or you might need to get some data from DynamoDB or Aurora database or any of the RDBMS, right? So in that case, when you run the post API, like get API, then lambda function, first lambda function will examine like it's get API or the post API. After doing that, there will be a next lambda function which will be called for doing the specific task for the get API. Then the lambda functions will do the work and return the data to the previous lambda function that trigger the next lambda function, and the previous lambda function will return the data back to the front end. This is how API gateway works. So like it's like the basic concepts of API, but in this case we have lambda in between for doing each of the tasks. That's only the thing. So another question is like, what's the maximum duration for the execution of lambda? Next one. How does AWS manages scaling in the serverless applications? Because we have been talking this since morning, the same thing in each and every topic. It auto scales by itself, nothing else. Like it depends on your use case. Like when using Lambda, it's gonna just add up the memory only. So, but in case of all of the things like when you have EC2 integrated on it, then it's just gonna like if it's not working properly, then a new EC2 instance might be added up. But it depends on the requirements that you are working on, and it AWS automatically decides. I can't also say that. It depends on it fully depends on the use cases. So if it's very large application that it will like it might use vertical also, like it might use horizontal also. That's the thing that we can't determine easily, because it's like we are using the services and it does auto scaling, right? It's managed by the AWS. In that case, like we won't be going deep into the infrastructure and like looking at like if it does the vertical or horizontal. But in the case of EC2, we will be looking into like what should we do, vertical or horizontal. So the managed service of AWS. So in that case, we won't be looking into deep for the auto scaling things, because they are doing by it themselves and it's working for us, and we are working with it easily. So what can be the common use cases for the serverless applications? Because I have talked lots of use cases over here today. That can be the one. Because data training is like, it's going to take lots of time, right? But Lambda will execute for 15 minutes only. And we need EC2 for that again. Yeah. Any other things, guys? For banking? That can be done, yeah. Image processing. So image processing also depends on which level of image processing do you want to go on. So if you want to like take out each and every detail of the image, then I think it won't be done by the serverless, because it's going to be huge for that. But if it's like just resizing the image or turning the color of image to monochrome, then Lambda will easily work for that. That can be also done. But in that case also, somewhere there should be a server to look on the overall things also. It's not like that. So serverless is also like behind the scene, there is server over there. But we are using the server of AWS, like paying the rent to them. But in this case, it's like when server is used, like if nothing is going on in the backend, all of the services are down by itself. But if something happens, then all of the required services get up again. After the completing the task, it will go down again. That's the main concept of serverless. No, like in that case, like it depends on the use cases as well. If the organizations have to on the platform for 24 hours, then they should use the EC2 instance. But for this specific tasks, like let's talk about a call center, right? So in that, users update the data after doing a call, right? So in that case, like if there are no calls at that day and you are just calling to 20 to 30 people only on the particular day, then it's like you gonna specify a lambda when the data when your user enters the data, then it's gonna be saved in the S3. S3 when the data is saved into S3, then the lambda is triggered and the processing of the data is done. Because like when we have the raw data, then we'll obviously need a clean data for us to visualize it properly, right? So in the part of data processing, it can be used, right? So also putting the data in S3, it might require a server in the backend rather than serverless. So it depends on how large you are going on for all of these things. So for the specific triggers only, you can use serverless. But if you have to run the platform 24 hours, then it's better to go on server, because managing serverless in that thing is going to be hectic a lot. Mm-mm-mm. So I talked about the pricing model of Lambda function. So can anyone say how it is worked, like how the pricing is done in the Lambda function? Based on upon the number of figures, because I think it takes around, like in the free trial account, you are going to get 1 million free triggers over there in free trial account. Yeah. And then after crossing that limit, you have to pay something over there. But I think it's gonna be $0.0020 for 1 million figures only. Yeah. And then it also depends on the memory it's using. The next thing. And then time, the lambda function as well. That's the thing. So again, don't you guys have any of the questions? Do I need to solve the questions in internet? So I would like to talk about Tom ARN as well. ARN as so ARN is like Amazon resource name, right? So in that it's gonna be like I'll share the structure of ARN at the beginning because that's a required thing. So in this case, the ARN format, right? So ARN is uniquely identifier for the AWS resources.
Hello.
Hello.
Sir, the consecration will start in like 2-3 minutes. So can we have a break for 5 to 10 minutes so that we will start the new topic afterwards?
Yes, sure, we can do that. So please inform after you come back.
Sir, in 10 minutes, we will be 10,
Yeah,
10
so
to 15 minutes, we will be back.
please be sure to come on time and please be sure to inform me after you come here, right?
Okay, sir. Okay, fine.